Part 2, Construction Simulation. In the second part, we'll again use the object animation capabilities that can be achieved in GDL. We will take a portion of a city in Google Earth, create a model of a building, and create a construction simulation animation in which the building will be built from the ground up in its planned environment with 3D buildings around it. Step 5. Bringing in data from Google Earth. We will bring two images from Google Earth, the image of a map of a portion of a city, and the image of a 3D view of the same portion with a modeled 3D building in it. We will not do these steps. Here you can see the steps that were done to achieve this. We searched for Miami, Florida in Google Earth. The application took us to the aerial view of downtown Miami. We selected a parking lot and decided to put a building in its place. We only panned to the desired position, but we did not rotate the view in Google Earth so it remained in top view. Using the File, Save Image command, we saved the image of the location to a file named Miami JPEG. Using the File, External Content, Place External Drawing menu command in ArchiCAD, we placed the image on the floor plan. We needed to scale the drawing correctly, therefore we went back to Google Earth and used the Tools Ruler menu command to draw a line from one corner of one building to another corner of another building. We read off the exact length of this line in centimeters. It measured 23,755.9 centimeters. Going back to ArchiCAD, we drew a line over the placed image of the downtown area between the same 2 points on the map image. We zoomed in as close as was sensible to make it as accurate as possible. We selected both the line and the placed drawing of the image, and using the Resize command, we resized them both graphically. The graphical resize operation's origin was one end of the line, and it was done in such a way that as a result, the line of the length measured 237,559 millimeters, just as in Google Earth. With this, we achieved that the image was enlarged to the correct size. Open the AC Guide GDL Chapter 10_2.pla file. Select the Read Elements Directly from Archive option. Here you can see the result of previous steps. Notice the blue line that was drawn and check that its length is indeed 237,559 millimeters. Activate the 10.2 Modeled Building Mass saved view in the Navigator view map. In this state of the project, you can see that the building was modeled using slabs and double slanted walls. At this point, we prepared the 3D window for animation. To do this, we did the following steps. We went back to Google Earth and switched on the layer called 3D Buildings. The application at this point displayed all the 3D model buildings available for Miami. We moved around to find an aerial view in which our building site is clearly visible and the buildings we plan to place there are not covered in that view by any other buildings. Using the File, Save Image command, we saved the image of the location to a file named Miami_background.jpg. We went to the Document, Creative Imaging, Photo Rendering Settings dialog. In the Background panel, we selected this newly saved picture for the background. We used the Load Other Object button in the Load Image from Library dialog to load the image file. We also set the size of the rendering engine window to match the size of the image so that the image as a background perfectly fits the size of the rendering engine window. We then went to the View, 3D View Mode, 3D Window Settings dialog, and chose Internal 3D Engine for the 3D engine. We want to use the 3D window as the source of the animation. Also, in the background field, we chose the As in Photo Rendering radio button. In the 3D Projection Settings dialog, we switched to the perspective view and tried to find a camera position in the dialog which would be close to where the camera was located in Google Earth. After this, we activated the 3D window. In the 3D window, we entered Explore mode and moved our camera position around until we found a view in which our designed building fit correctly into the surroundings shown in the background image. Activate the 10.3 perspective of building mass saved view in Navigator. In this saved 3D perspective view, you can see the result. It's a good idea to save the camera position and not only the view resulting from it. Therefore, we used the View 3D Navigation Extras, put a camera into the Path menu command, to place a camera at the current position seen in the 3D window. Since we want to create an animation, we needed at least 2 cameras. Therefore, we placed another camera extremely close to the one we had just placed by dragging a copy of that camera. We set the in-between frames for those 2 cameras to 99. This way, we will have 100 frames total in our animation. Go to the Camera Settings palette and click the Path button. In the appearing dialog, select the Everything option from the drop-down list below the Display Options field. Click OK to close the dialog. Activate the 10.4 camera positions saved view. Here you can see at a very high zoom level the 2 cameras placed on the floor plan.